This is a book about numbers. Each chapter talks about one number. First page gets the number big, and then start conversation about that number. So tempting to think about the first chapter, whether it should be number 1. Chapter 1 should be about number 1 and number 2, because maybe 1 and 2 must go together. Because we can think of ourselves as 1, and then we're always looking for a number 2. Is there another one out there who can be my friend or my enemy, my lover, my child, my mother? So chapter 1 is actually 1, 2. I have 1 stone I can throw, or 2. Is there one bird, or are there 2 birds I can throw the stone at? Because once we start counting 1, we count 2, and then we count the rest of the numbers, at least the digits in our hands, the decimal system 1 through 10. We don't call them 1 or 2, but we had this concept. We must have had very early on this concept of 1. When I was a fetus, my concept of 1 was 1 in the universe. I was 1 with everything. The universe was me, and I was the universe. The universe fed me, gave me oxygen, took my waste away, protected me, kept the temperature at the same level every moment. There was just 1. But it wasn't just me, it was just 1. It was everything, and I was 1. And then I was born, and besides the physical pain of being born, that transition from that paradisiacal environment to this harsh new reality, there was also the awareness that there were 2. Mother now wasn't me anymore, and I cling and I try to remain being part of Mother. I suck her nipples as she fed me. I cry and I cling and I try to remain 1, but slowly the feeling sank in that we were 2, and then there was another one, this guy who got into the picture. This hairy man with deep voice. At some point we think there's only 1 love, and there are 2 and more. 1. Most counts start at 1, some start in reverse. The launching of the rocket, 10, 9, 8, 1, liftoff. Being number 1. One God. monotheist religions, I guess they go back to this fetus moment when we believe that it's just one. And then we can count with the concept of one at least to 10. And in a decimal system, from 10 we manage to count bigger and bigger numbers. In a binary system, we count with just two numbers, actually. One and nothing. And that's chapter 2, 0. What a concept. A number for nothing. The count is nothing, the count is 0. And binary Boolean algebra is based on just 1 and nothing. 1 plus nothing is equals 1. Nothing plus nothing is equals nothing. So far, so good. But here comes the shocker. 1 plus 1 is 1. 1 plus 1 is equals 1 in Boolean algebra. Shocking. 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, only 1 times 1 is 1. That's conceivable, but 1 plus 1 is 1. This Boolean algebra is more thinking in terms of switches, on and off. If it's on once, it's on, and if it's on twice, it's still on. So here there's no need for two, there's just nothing and 1, 0 and 1. So I was fooling you with chapter 1 when saying that 1 also implies 2. Because no, 1 implies 0, 1 implies nothing. I am 1, I am nothing. I am alive, I am 1, I am dead, I am 0. I have food or I don't have food, 1 or nothing. I'm in love or I'm not in love, 1 and nothing. I'm in love and I'm in love again, it's still love. 1 love plus 1 love is 1 love. 1 hunger plus 1 hunger is 1 hunger. There are no 2 hungers. 1 joy plus 1 joy is 1 joy. One death plus 1 death is 1 death. Zero. What a concept. It took a long time in civilization to figure out a 0, to write it down and put it into our algebra, our multiplications, our summations. That opened up an entire way of thinking and counting and calculating. There's a bird trying to catch this big fly. So there's 1 fly, and she approaches and steps on a leaf, and now there's no fly, 0 fly, but the fly is somewhere else. There's 1 fly again, and she lurches, and the bird moves again. 0 fly again. 0. And then what happens when you try to do algebra with 0? 1 plus 0 is 0. 1 times 0 is 0. 1 divided by 0 is infinite. 1 divided by 0 is infinite? Holy infinite. Holy infinite. How is that possible? How can I go from one fish to an infinite number of fishes because I divided by 0? Okay, I have one fish. I divided just to myself. I get one fish. 1 divided by 1 is 1. I'm sharing my fish with someone else. We are 2. So 1 divided by 2 is 1/2. But 1 divided by nothing is infinite. My fish divided into nothing is infinite. My fish, I'm not sharing even with myself. I'm not sharing with anybody. My fish not being shared becomes infinite. My freaking fish is infinite. It has become infinite by not eating it. I guess it rotted away and became infinite. As I've been saying for a long time, that we become infinite. That's it. 1 divided into nothing is infinite. 1 into nada is infinite. There it was all the time. You don't believe me? Think it this way. One divided by 1, I'm taking the fish, is 1 fish. It's 1 meal. 1 divided by 2, 1 divided by half, I'm taking half the fish in a meal, is 2. 1 divided by 0.5, we haven't even talked about decimals. 1 divided by 3, 1 divided by 1/3, 0.3, I'm taking just 1/3 of the fish in my meal, it becomes 3 meals. So if I take 10% of the fish, 0.1 of a fish for my meal, 1 divided by 0.1, I have now 10 meals. If I take 1% of the fish for my meal, 1 divided by 0.01, it becomes 100. I have 100 meals. If I eat 1% of the fish, I have 100 meals. So if I don't eat at all, I have an infinite number of meals. So when I'm not eating this fish from this river because I love them too much and because it's not sustainable and because I'm not a predator anymore, I'm having an infinite number of meals. I'm taking the 1 fish and dividing it into nothing. I'm not taking any of the fish. So I have an infinite number of meals. And that's basically an infinite number of fish in the river, so I have an infinite number of meals. Now infinite is curious, infinite is infinite, so infinite plus infinite is infinite. A super billionaire can make another amount of money as much as he has, and he's still a super billionaire. He has infinite buying power. He makes as much money as he had before. He still has infinite. Infinite multiplied by infinite is still infinite. This wealthy man, in his quest to be wealthy, makes every one of his children wealthy. And they are still infinite in buying power and wealth. So chapter 3 is about our infinite. Chapter 3 is infinite, which we symbolize it by a sleeping 8. An 8 on the side is an infinite sign. It's 8 that has laid down and stretched out, and it's an infinite sign. One divided by infinite is nothing. My fish divided by an infinite number of people is a nothing meal. Everybody gets nothing. Chapter 4, after chapter 3, that would be a good place to put pi. Yeah, it's time for pi. Not the sweet contraption that rots our teeth, but apple pie, no sugar. Make pie without sugar, please. Yums. The baking of apples. They get sweet enough just by baking. No butter either. Maybe just bake the apples in a solar oven. Want a solar oven to bake apples from my apple orchard. I want an apple orchard. And then in my apple orchard under an apple tree, I'm going to read chapter 4, which is about number pi. Most people have heard of number pi. Some people know it's a little more than 3. I learned as a kid that is 3.14159. Most people are happy to do math with 3.14. Some of the kids were happy with 3.1416. But I insisted on using 3.14159. Having 5 digits after the decimal point made me feel powerful, and it made all my calculations a lot harder. And there was little precision added by having the 5th digit after the decimal point. But what's with all these these numbers after the decimal point? What the heck is going on with this number pi? Why is it so confusing? Well, that's what's called an irrational number. A number that you keep adding digits and you never have the number. Pi has an infinite number of digits after the decimal point. How is that possible? Well, it's one of the conundrums of numbers. And it's very simple. Think of a circle. People must have wondered for a long time, if you take a circle, what's the relationship between the diameter, if you walk across the circle, as opposed to going around the circle? So this farmer has a circular farm, or this religious person has created a circular path and walks across the path and measures the steps. Or he creates the path by first measuring across. So I like to create a circle that is 10 meters in diameter and sit in the middle of it. I feel contained in this circle, and I remain in the circle. I keep the inches of the word out of the circle. So I count 10 steps, and then I trace a circle that has 10 steps in diameter. And when I walk on the edge of the circle, I'm curious to see how long this circle is, the circumference of this circle is. And I walk, and this circle I created that has 10 steps in diameter, when I walk around it, I don't get an even number of steps. I walk and I count, and I'm like, no, it's something wrong, and I do it again, and the same thing happens. And I count, and every time I do it, I count 1, 2, 3, 20, 30, 31, and a little. I count 31 and almost half a step. I don't have my 10-step diameter circuit doesn't have a whole number of steps around it. It's somewhere between 31 and 32. Very close to 31 and a half, a little less than 31 and a half, 31.4. How's that possible? Well, that's pi for you. Entire trigonometry is based on calculations around the circle and the square and the angles, and the number pi is constantly present. You can measure an angle in terms of degrees, 360 degrees to go around. You know, they make the 180 turn when you turn around. But the 180 turn is also a pi turn, because the circumference is 2 pi, is pi times the diameter, or 2 pi times the radius. Then we call the full around the 360 degrees 2 pi, or half pi. A 90-degree angle, a square angle, is pi divided by 2. Chapter 5. Well, if chapter 5 was about 4 was about pi, 5 is going to be about E, Euler's number. An exponential number. This number comes from, maybe one of the first things it comes from is the catenary. If you have a string hanging, it creates a curve that is not a parabol, it's not a semicircle. It creates this string hanging, this cloth line hanging just by its weight, have a special curvature. And that's a catenary. And when mathematicians tried to calculate it, they came up with something that was a different number. It was the E number, 2.71, if I remember right. 2.7172, that's what it was. Oh boy, and it did have applications. Once they figured out the number E, they figured out lots of curves and lots of phenomena that had exponential growth. Became very essential in probabilities and stuff that is not absolutely predictable. If you toss 10 coins up in the air and they then fall down and then count how many coins are face up, in average you should have 5 coins, but sometimes you're going to have 6, 4, 3, 1 coin face up, which will be very rare. And then you make a graph of these happenings, you get to what is called a Gaussian distribution from Gauss, the mathematician Gauss. And that distribution has the E number in it. The E number now. You know who's coming on chapter 5? E number goes into a later chapter. Chapter 5 is the I number. I. We have 1, 2. We have 0, infinite, pi, and now we have I. Yes, I like in you. I eat. The pie has 2 numbers in it. I is a number too. Not only pi is a number. I eat the pie. Build a phrase with 3 of the numbers we had talked about. I eat the pie into 0. I is a number. How is that possible? That's a trickier process than pi. And perhaps one of the easiest ways to think about it, or less difficult ways to think about it, is the square roots. Think of squares and how we calculate the area of a square, how if a square is 10 meters on the side, it's going to have 100 square meters, or 10 feet on the side. You have a room that is square and it has 10 feet on each side. Then you have 100 square feet of room. You want to put a new floor on that room that is 10 by 10 feet, a very small room. You need 100 square feet of flooring for your new floor. Pretty easy, eh? And then you can use it the other way around, and that's what the square root is. That is when you calculate the side of your room based on the area. Somebody took off the flooring of this room and counted 100 square feet of flooring. That means that the side of the room, if it was square, was 10 feet. That's called the square root. Square root of 100 is 10. Square root of 4 is 2. Because if I squared has 2 on the side, it has 4 squares inside. Square root of 4 is 2. Now, what happens if you are so curious that you want to talk about negative numbers and you want to take the square root of a negative number? You want the square root of minus 100 or the square root of minus 4. That doesn't make any sense in principle. Your room now has minus 100 square feet of flooring, or minus 4 square feet of flooring. Yeah, why not? Well, that, my friend, is the square root becomes then an imaginary number, and is denoted by putting the letter I next to the number. This is the news for you if you never heard of this, and maybe this is not the best way to explain it, but the square root of minus 1 is I. I squared is 1, minus 1. So if I square myself, I become minus 1. I guess I'm dead by squaring myself. I. An imaginary number, the square root of a negative number. Mathematicians make graphs with these numbers, and you have a complex number that has a real part and an imaginary part, and it can be shown on this Cartesian graph. And then this is when it is really the mathematicians had orgasms just thinking about it or figuring it out, was when they brought together three of the numbers we had talked about: pi, the e number, and imaginary numbers. Because behold that an exponential number can be exponential of a complex number can have a sine and a cosine part. E to the ix is equals to cosine of x plus I sine of x. And if you can understand that one, you have made a lot of progress in your algebra. Chapter 6. So chapter 1 was 1, 2. Chapter 2 was 0. Chapter 3 was infinite. Chapter 4 was pi. Chapter 5, waves coming from that boat. Chapter 5 was I. So chapter 6 shall be about what number? Chapter 6 is going to be about number